Thank you, Daniel. It's great to be back here. We did some talks here in the past. It's great to see some faces again. So here's what we'll look at this evening. 4 sections. We'll look briefly at a kind of the past history of continuous delivery, where we are now. We'll see what we can learn from what you might call cloud-native software. Have a little look into our crystal ball, into the future, and look at just over 10 years from now, what might your production environment look like? And then towards the end, I'll try and convince you that it's essential that we have a focus on operability to make any of this stuff work. If you have any questions, just raise your hand anytime. I might decide not to answer it, but you can always ask. No, I'll leave space at the end for answering the questions, even if I don't answer the question at the time. So this is, if you want to go to sleep, there's some nice comfy chairs at the front. If you want to go to sleep, then before you do, just look at this slide here, and this is the only thing you need to remember for the entire talk. So continuous delivery and operability practices are central to our digital future. That's the key message. This is me from a few weeks ago, and I founded and run Conflux consultancy, and we help organizations adopt and sustain good practices for building and running software systems. So a brief history of CD time. Back in the dim and distant past, this is 1999. So Kent Beck and friends published Extreme Programming Explained. So this is based on practices that had been developed through the 90s, well, actually going back into the 70s, but anyway, coming through the 80s and 90s, distilled into Extreme Programming, or XP. Shortly afterwards, Mary Poppendieck and Tom Poppendieck published Lean Software Development, which was very influential and well respected. We then, in fairly short succession, had books on continuous integration, agile testing from Lisa Chrisman and Janet Gregory, growing object-oriented software guided by tests, known as the Goose book, Goos. If you haven't read that, go and read it. And then in 2010, the book called Continuous Delivery by Jez Humble and David Farley. After that, fairly soon after that, we actually started London Continuous Delivery Meetup Group, this Meetup Group here. So we started that in 2012, which was basically 2 years after the CD book was published. Shortly after that, we started Pipeline Conference, which ran for 5 installations, 2014, 2018. Who has attended Pipeline Conference, by the way? So you'll know what that was like. We've actually got videos from all the videos that we have for Pipeline Conference, so all about continuous delivery, are all online. If you go to pipelineconf.info, you will find all those videos. So all the materials there, so you don't need to feel like you're missing out. And then here we are today. This is another important milestone in continuous delivery, because you're here, and that's the important thing. So I just want to say a big thank you, by the way, to the team at Engineer Better, Daniel, Dan, Ivana, for taking on the Meetup Group and giving it a new home, a new lease of life. I think it's going to be awesome. You can already see the new branding is far better than what was there before. So that's really great. It's going to be an excellent group, I think. The NJ Better are really good supporters of the Meetup Group and the Pipeline Conference as well. So I think you're in really good hands with a new team. Here's a quick Google Trends look at the phrase continuous delivery. Going back to 2009, you can see that no one was really using it before the book came out. And since the book came out, it's been increasingly popular to the point where now basically it's as popular as it ever has been. It's still completely relevant, and I think hopefully you'll see from this talk, it will continue to be relevant as a practice and discipline for the foreseeable future. So let's just remind ourselves what we mean by continuous delivery. We mean exactly what it says on the book cover, and that is this: reliable software releases through build, test, and deployment automation. That's exactly what we mean. We don't mean deploying to production every day. We might deploy to production every day if that's suitable, but we don't necessarily mean that when we talk about CD. We're talking about the use of automation across build, test, and deployment to give us reliable software releases. And this book, I've been really trying hard to find recommendations and advice in this book which is no longer relevant. And I have yet to find a piece of advice which is no longer relevant. I've been trying really hard. But some of the technologies have changed slightly. Some of the examples they give are superseded. But the core practices and the core approach is absolutely bang on relevant today. And part of the reason for that is because it uses the scientific method. So we have a hypothesis, we go and test it. We don't assume that what we're about to do is correct. We set ourselves up to learn from what we're about to do, and that's why continuous delivery works really well, amongst other reasons. Really importantly, continuous delivery is not what we call a feature factory. Continuous delivery is not about pushing out feature after feature to production from a big old backlog of stuff that needs to get shipped. Continuous delivery is a way of experimenting with what we're doing to help the organization self-steer towards better business outcomes. That's completely the opposite mindset from just pushing out a whole load of features. We need also to realign our software architecture to enable this stuff to happen for us to be able to do this safely. So there's some sort of sense of changing the shape of what we're building in order to enable this kind of approach. We make sure we set things up so we've got very rapid feedback from what we're doing, and we use deployment pipelines. The phrase deployment pipeline was invented by David Farley, who was a co-author of the Continuous Delivery book. That's where it comes from. And he actually didn't mean a pipeline like this. He actually meant a pipeline as in a CPU processor pipeline. He didn't mean a big fat pipe like this that water flows through. But the purpose of the deployment pipeline is not just to execute tests, it's to help us get rapid feedback on what we're doing. And again, that's a mindset shift. We try and set up everything so that we can get rapid feedback on what we're doing. We're optimized for that rapid feedback. It helps to encourage good technical practices. In fact, we do need good technical practices if we're going to do this delivery stuff rapidly and safely. So for example, TDD, but other practices like behavior-driven development, and so on as well. Because we can't just expect to push out poorly written software and have no consequences. Continuous delivery tends to work best when we have a sense of team ownership over software and services, so that we don't have multiple different groups of people trying to effectively fight over the same bit of code in version control. So we tend to end up with kind of alignment between services or products and teams that are owning them. And those teams look after the same bit of product or software or service on an ongoing basis, effectively. If you want a quick overview of some of this stuff, then have a look at this book that I co-authored with Chris O'Dell, who was one of the founding members of this Meetup group too. Even if you're not using .NET, it might be worth a look because the book is actually a key text for the master's course in software engineering at UCL here in London. I actually bumped into the course convener today at a conference, and this is 2 years after. The book is still used as a key text because of the way that we explain some of the continuous delivery concepts. So you can get access to it via O'Reilly Safari subscription, and if you follow the link at cdwithwindows.net, you'll be able to buy a paper copy as well. Any questions about that first stuff? All make sense? It's probably fairly straightforward. So what can we learn from cloud native? I put it in scare quotes because it's a bit of a false term to an extent, but you know, there are some things we can learn. And the first thing I think we can learn are that there are 4 key metrics that have been identified in the book called Accelerate by Nicole Forsgren, Jess Humble, and Gene Kim. And these 4 metrics were derived from 5 years worth of global studies, interviews, and Q&As as part of the State of DevOps report. And so Nicole Forsgren got a PhD in statistics or something similar, I can't remember. Anyway, she's able to use her deep knowledge of how to interpret numbers and relationships between different sets of things to be able to identify that these 4 things are key practices that help organizations to be high performing. So the lead time is the time it takes, depending on how you count it, but let's say it's the time it takes between committing to version control and that change being in production, running. The deployment frequency is simply how many times per day, per week, per month we deploy to production. Mean time to restore means, on average, how long does it take to restore service in production from an outage? And change fail percentage is simply what percentage of attempted changes into production failed. So organizations that are really flying have a very short lead time. They have a high deployment frequency. They have a short mean time to recovery. And they have a low change fail percentage. And these four metrics here correlate very strongly and are very strong indicators of organizational performance. These are things which, if you're doing these things right, you're probably on the right track. And we've now got enough understanding of the practices that work in a kind of cloud context, cloud native context, if you like. We've now got enough understanding of the dynamics, the social dynamics, the kind of technical practices that enable these things to be able to take that learning and apply it in other areas as well, other contexts, not just cloud, but apply those kind of engineering practices and organizational practices outside of a pure cloud context. So one key aspect is that the operation of these systems is extremely transparent. We've got very clear ways to be able to plug in and observe what's happening in these kind of cloud systems. Another property of these kind of systems is they are designed for automation. They're designed for automation and using code so that we can actually trace back all the way to version control and see the nature of the change that we've just made. But crucially, they're API driven. We're expecting to run these systems from command line or from a shell. We're absolutely not expecting to be pointing and clicking at any of this stuff. Now, this might seem all very obvious, but the point is that we've actually, in the last kind of 20 odd years, we've learned this stuff the hard way, if you like, in the kind of cloudish industries that we're now in. So it does seem normal to us. There are loads of industries outside of cloud where this stuff is freshly to be discovered. So we've come quite far. We've got continuous integration, continuous scanning for security purposes, continuous performance, continuous monitoring, deployment, kind of continuous right sizing of our Kubernetes clusters. This kind of thing is all now fairly standard, but it certainly wasn't standard 10, 15 years ago in our sector. So these are the things that we can bring to other areas of industry or other kind of sectors. Some examples of platforms or products or services that have really kind of helped or are doing really well in this space. So GitHub is a major one to call out because who uses GitHub kind of on a regular basis? So it's basically magic, right? It's yes, at the core there's Git, which is just a load of bash scripts, fine. But it is, right? But their vision was this kind of social coding sitting around the pure version control repository thing, being able to see visual diffs, being able to send a pull request. Things like this are not inherent to Git. They're effectively what GitHub invented, and that's incredibly powerful way of communicating change and sharing change. So I was talking to the team at GitHub today at the conference I was at, and they're talking about the fact that through the use of GitHub, teams of researchers around the world are able to collaborate on the rate of destruction of coral reefs because they're able to share the data in a way which allows them to track how that data has changed over time. This would be very, very difficult before something like GitHub has come along. It's hugely influential. We just kind of think it's just version control, but actually it's hugely influential for helping us to provide a foundation for kind of text-based changes in lots of different contexts, not just software. We might happen to have Java or Python or whatever, but we can use the uses are potentially almost limitless. We've started with software, but the future is to use something like GitHub for all sorts of other kind of text-based stuff. So Kubernetes, we're learning a lot of stuff about kind of big distributed systems, how to do rolling restarts, how to manage kind of clusters of things, and we'll see in a little bit that that's influencing the design of some products in the IoT space, so in the Internet of Things space. And then tooling like CircleCI, who do really great kind of cloud-hosted, SaaS-hosted continuous integration and pipelines. They're doing really interesting stuff in kind of lots of different sectors, and reducing the cognitive load on development teams because a lot of the hassle is taken away. Let's Encrypt, who are providing TLS certificates through automation. That would seem like magic to someone if you talked about that only, say, 5 years ago, or certainly 10 years ago. The idea of kind of fully automated cert renewals would be completely magic, whereas now that's just normal. And SNCC or Sneak, depending on who you ask, doing open source vulnerability scanning and so on. And we've now got to a point in kind of cloud native land where we've solved a huge number of really important kind of primitives, which actually open the door to these kind of techniques being used in a whole range of different situations, which we'll look at next. A key part of this is this design for version control. This is like a really key thing, which we kind of on a day-by-day basis probably forget, because this is like really obvious for software people. This stuff is completely unobvious, completely not obvious for people outside software. And that is this. We use text files, not binaries. We've got fully trackable change history of our specification. The transparency with which we're working helps to drive innovation, because people can see what's happening and can see the nature of the change and fully understand it. It gives us ability to really reason very powerfully about the nature of what we're doing. That's incredibly powerful. And on a more prosaic level, because we've got kind of webhooks and similar kind of APIs, we're able to trigger some automation on a change. This stuff is magic, right? This is totally magic stuff. We're totally used to it every day. But it's a incredibly powerful set of primitives for doing things in different industries. Back in 2012, Gary Groover and colleagues published this book, which is a little bit of a mouthful, A Practical Approach to Large-Scale Agile Development, blah, 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 HP, LaserJet, firmware, something. But in it they describe how they adopted a set of practices which are effectively very similar to continuous delivery for developing the firmware on their LaserJet printers. Now, they are not deploying firmware to printers daily. That's not happening, right? What they're doing is a set of engineering practices with version control and integration and testing that help them to hugely improve the quality and reduce the costs around firmware development, gets deployed onto a printer, and then the printer gets shipped. And that's, by and large, that's the last time we see a software update. So we know this stuff has been happening at scale at least since 2012, and elsewhere in other organizations too. This is really interesting. There's a movement for hardware designers called Zero Diff, which is an approach that uses a lot of the practices that we're talking about, including continuous integration. This approach aims to help. So the name Zero Diff comes from the fact that if you're making a hardware electronics, you tend to have one board for prototyping and one board for production. So that would be like having one set of source code for testing and development and one set of source code for building and running in production, which obviously we don't do. We have the same set of source code, right? That's a continuous delivery practice. And Zero Diff has taken kind of a leaf out of the CD book by saying, let's have the same board design for prototyping and for the production run. And that means that the dynamics around creating the kind of electronics board are different. And if you're interested, have a look at the Zero Diff website. There's a page that talks about using something called Team City for continuous integration, which means every time that you check in some code, it'll build your tests. The point there is that people in the hardware world, this stuff is magic. And we can laugh, it's fine, but the good thing is, we're in a position where if we've got some kind of interest or experience in this area, we've got the ability to actually add a huge amount of value to, in this case, kind of hardware electronics, by bringing our understanding of these kind of practices into a completely different field. And I think it's worthwhile separating what we mean by kind of software-y stuff or digital. And the first thing is, we've got these rapidly developed services which are accessed from like a personal computing device. That will make sense. That's how you do online banking, or that's how you buy your music or whatever from online stores. But another strand is rich telemetry that goes along with that. That feels to me like a separate dimension. So even if we're not actually building a service or product out of software, we've got a load of telemetry which we can use, which is software-based, which you can plug into an existing thing. And the third strand for me is highly effective ways of working that we've discovered by building software-based products and services with a load of telemetry. So things like agile software development, things like kind of Kanban for managing work, understanding how to track and use metrics to enable us to make business decisions, this kind of thing. So we're in a position where, because we've been working in the software industry, we've discovered a whole load of really effective practices, and now we're actually kind of poised to be able to take this awareness and these practices out into very different different parts of industry that feel actually quite different, that are not primarily software-based. All right, so here's a galaxy of industries and places where software might exist. Our current cloud native stuff sits about here. It's not at the center of the galaxy, but it's not at the very edge either. It's kind of on one of the spiral arms. VB6 development is right at the end of the spiral arm. That's going to fly off into the midst of the interstellar void. Thankfully, have they finally killed it? I think there was a news story recently, right? Where anyway. But the point is that healthcare, agriculture, manufacturing, transport, textiles, as a whole kind of central galactic core of industries and areas which are ultimately going to be much more transformational than the current crop of kind of cloud native services. Okay, what can we do? We can buy stuff, we can do our banking, we can stream music and video and a few other things, but compare that to healthcare, agriculture, manufacturing, transport, and what you wear, it's actually relatively non-invasive, whereas this stuff that's coming in the next decade will seem hugely transformational compared to what we've been doing so far. So we've only really eaten a tiny slice of the pie as software opsy kind of cloud-based practitioners. There's a load more pie to get into. So, what will your production environment look like in 2030? Well, it's kind of already here. This is Toyota's latest factory, but their factory is software configurable. You can change how different bits of the factory interact and where they sit and where they operate by changing some code and getting the bits of the factory to update themselves. So at the bottom is the hang on, is this working? Yeah. At the bottom, this is the traditional old factory with old style factory with lots of kind of gantries and things hanging down. In the newer factory, because of how they've changed the way they work, but they've also changed how they're using telemetry and software and various other things to enable the factory to be reconfigured much more easily, to be much more open. John Willis, who is a co-author of the DevOps Handbook and has been doing this stuff for a long time, saw this recently, and he called John Willis's phrase is factory as code. So we're used to configuration as code, infrastructure as code, whatever. This is factory as code. The factory is now software configurable, or will be soon, software configurable to build new things. So your production environment in 2030 might be a literal production environment in a Toyota factory. And you configure it using software. How do you test it? We don't know some of this stuff, but we know that we've got the primitives to be able to have a good stab at doing this. I think it's amazing. I don't know. I just think it was incredible, but not entirely surprising given Toyota's history in innovation in this kind of space. Slightly more down to earth, but actually still quite revolutionary is approach that a company called IFM Electronic is taking with sensors in factories. So a sensor might be to measure how many things are going past. It might be measure the height of something. It might measure the temperature or weight or any number of things. It's measuring a discrete thing. And until last year, if a sensor failed, someone, a human being, would have to come along, swap out the old sensor, put a new sensor in, and then spend about 2 or 3 hours calibrating it. So very, very manual. Now, they plug in a new sensor. The central kind of control unit detects the sensor, detects the type of sensor it is, knows where it is in the kind of conveyor belt in the factory, and automatically pushes down the configuration. So now we're at a point where we're able to reconfigure literally our production environment in a fraction of the time it was before. And we're doing that through a kind of configuration as code thing. Now, I don't know whether, I think at the moment, the configuration is not stored in version control, not in a Git type version control repository, but it's only an additional step to use a kind of Git-based backend for some of this stuff so that they get the extra benefits of that. So we're now able to at least reconfigure and confirm the sensitivity and calibration for all of our sensors effectively using kind of software techniques. The sensors look like this, by the way. These are the ones on the top right are kind of some control boards. The actual sensors are these kind of, the things at the bottom here. And that's when I went to their stand at a trade show recently. Your production environment might be 14,000 insulin pumps, which are providing diabetics insulin to keep them alive. So there was recently some breakthrough in the interoperability between different vendors of insulin pumps, where they agreed on a common standard that is like an open standard, and so people will actually be able to start building, updating source code for these things. This is literally life and death now. So your production environment is literally life and death if you're providing the software and runtime for one of these insulin pumps here. Does that make you scared? It makes me scared, but we've got the practices that enable us to do this safely. It's continuous delivery. It's all the practices we've just talked about in terms of version control and continuous integration and so on. Your production environment might be a fleet of tractors that are now, although there's a human being inside the cab, they're not really driving very much because the steering wheel is controlled by a combination of GPS and 3D sensors on the front of the tractor that show the optimum kind of ploughing and seeding route across the field, based on all sorts of factors. And if that goes down, then well, no one's going to die, but it's quite expensive because we've only got a short window for harvesting the crops or for planting the seed or whatever it is. Your production environment might be 1 million sensors spread across 100 buildings across a few different cities. And these sensors are there for looking at things like occupancy of desks. They're trying to optimize the space. They're trying to work out whether certain areas are too noisy. They're trying to look at whether the heating and air conditioning in different parts of the building are actually working effectively and then doing something about it before people start to expire. This is already happening. A company called Open Sensors, based in London, is doing this stuff already. Not quite at the million scale, but heading towards that. And I know for a fact that they would strongly welcome people with strong software chops to help what they're doing. Your production environment might be many thousands of advertising screens with facial recognition and micro-targeting. Does that feel creepy?
Yes.
We already have it in the web, right? Because your browser configuration, which sends down a whole lot of extra gumph about what plugins you've got installed, is as good as facial recognition. So this stuff already happens. This micro-targeting already happens in I've seen prototypes in the UK.
Leicester Square.
Leicester Square, okay, fine. And it definitely happens in China and places like this. So whether or not you like that, that might be your production environment. How do you test that it's working properly? What's the effect if it's down? Do we care? I don't know. But someone's going to pay for it, so that might be your environment. And so on. So we could have crop sensors which communicate via LoRaWAN. Anyone heard of LoRaWAN? 1, 2, maybe. So this is long-range, wide area network. Extremely slow bit rate, 128 bits per second. Very, very slow. And so it's operating in the non-regulated radio frequency spectrum. So you can only send one packet every minute. So it's absolutely not for downloading Netflix across this thing, but it is perfect for a nice little sensor, because how often do you need to sense the soil moisture in a field? Once a minute is probably all you need. Particularly with things like Brexit causing shortages of people picking crops, then this is going to drive in this country an increase in the use of vertical farming. So your production environment might actually be a whole load of robots going around a vertical farm picking fruit. Some of this stuff's already happening. There was a big investment by Ocado, the delivery company, into the UK's or Europe's biggest vertical farm, which is based, I think, in East Yorkshire. So this stuff is already happening. One company that's doing some really interesting work in this space, if you're interested at all in smaller devices rather than big cloudy things, is called Belena. They've got offices all around the world. I think they've got an office in the UK, maybe more than one. Barcelona, I think, is the main thing. But they do some really interesting things with containers on tiny devices. So they've written their own Linux OS that is extremely small, that can run on a tiny little kind of Raspberry Pi sized device. Don't worry about the details, but basically we've got git push goes to git. They build some stuff. There's a mini Docker registry thing, and then it pushes the things out to like your drones or your EPOS terminals and various other things like this. Really interesting stuff. So they're learning. This is the organization that's learning from kind of the Kubernetes, where we're talking about quite big estates. They're doing this stuff at a very small scale, which of course means if you're running a kind of disposable container on your tiny IoT image or tiny IoT device, then actually you have a way to avoid bricking that device. So bricking, in other words, just turning it into a useless piece of junk. Because if you send down firmware in the traditional way into a piece of hardware, there's a chance that you might accidentally have disabled the network, so then it can't receive a new update or any commands. But if we're taking a much more kind of cloud-ish approach to IoT, then we've got a chance of kind of applying some of the more well-known paradigms to help us manage kind of a big fleet of IoT devices more successfully. That's super interesting stuff. Maybe your production environment is a firefighter's or the suit that a firefighter wears as they're going into a fire. And maybe there's like 100 firefighters tackling a big blaze, because there's all sensors on the suit, and the suit itself might change shape or change some property of the suit if it detects that the firefighter is going to get burned. So this stuff they're all prototypes in this space already. Companies like Hainsworth are based in Leeds, so I've been around their factory. They're not doing exactly this, but they do provide. They are working on some interesting smart fabrics, and there's other companies around in the UK in particular working on some very interesting kind of smart fabrics. Companies like that are starting to integrate electroconductive thread and so on into clothing. So your production environment might look like a whole load of fire retardant and protective suits. We did some work with a company that makes home robot vacuum cleaners. Your production environment there is a combination of a cloud system, a mobile phone to control the robot vacuum cleaner, and a whole fleet of robot vacuum cleaners themselves, busy cleaning a house, sending data back, sending reports on what they've crashed into or where they're stuck. And that kind of home automation stuff will only get more pervasive, right? this is a little plug. So we've exploring this space in a kind of digitalization for manufacturing thing. If you're interested, then have a look on our website at confluxdigital.net. It's a super interesting space for me because I think there's a huge opportunity to get involved in some really interesting step changes. It looked like a step change if you're looking back in how we build things, how we operate things, real world things, rather than, if you like, just software. So there's some problems that, for me, caused me to think that we need a renewed focus on operability. So just a selection of problems. A lot of these devices that we're talking about, whether it's a factory conveyor belt or whether it's like a drone, an aerial drone for photography or delivery, or any number of these kind of IoT type devices, they're not ephemeral. We can't just blow them away like we would kind of a cloud system or a set of containers or something. They're physical. They're going to stay there. So they're non-ephemeral. And I think that there'll be a class of devices or certain cases where that'll just never go away. There'll always be a real physical device there, and that will put certain constraints on things. But like we saw with Belena, if we can actually take some aspects of kind of cloud native, like micro containers and like a micro cloud, and run effectively like a micro cluster on something like a Raspberry Pi or something, then maybe we can start to apply some more familiar patterns and not feel so constrained with the hardware that we've got. We will definitely have to contend with networks that are intermittent or that have limited bandwidth. Things like LoRaWAN, but just kind of 4G or 5G. You go with 5G, it's very sensitive. So if you go behind a wall or a bus passes in front of you, maybe the signal drops out or it drops down to 3G or whatever. So there's network transition. We kind of maybe don't have to think about that so much with kind of pure cloud, but we will definitely have to contend with it in the future. So we know what the pattern is there. It's asynchronous stuff. It's eventual consistency, kind of event-based messaging type stuff. So we know the pattern. We've sort of discovered that. Let's apply it properly, and not expect that we've got 10 gigabytes available to 10 gigabits available on every single network. There are definitely cases where a lot of processing can't be centralized to the cloud. Certainly at the moment, there's no way that you're going to get a manufacturer to push all of their control data straight or have all of their control systems in the cloud controlling their factory. They want the control stuff in the factory space itself, which is kind of where it needs to be because there are some protocol limitations with the kind of SCADA kit. So it might be difficult to get to if you like to kind of turn that cloudy. So you might have to deal with there being kind of edge systems, edge processing systems. But we can maybe use this cloud native stuff and push that into the kind of on-premise data centers and so on. Difficult to see exactly what's going to happen there, but some of the physics means that they need very, very tight, close communication with some of the factory systems. And obviously, if we're talking about insulin pumps, then some of the failure modes of these software systems are going to be life-threatening. So how do we deal with that kind of situation? We can't just say, "Oh, I just restart it. That container crashed or that pod failed. Just restart it, be fine." Well, I don't think you can say that to the diabetic whose insulin pump just failed, and then now they're either on the floor or they've. We can't just take the same kind of, I guess, fairly blasé approach. It'd be nice to be blase, right? So we can just spin up a new one automatically. That's kind of nice, but we can't take the same approach everywhere. So we need to, identify the failure modes and test things more thoroughly with this kind of focus on operability. So being really clear about the ways in which things can fail, identifying different failure modes, making sure that kind of diagnosability, testability, monitorability, securability, these things are all things that we actually build as first-class features into our software. We're not just optimizing for what we can see on a screen. We're making sure that as part of what we're offering in that feature set is operability, is something that actually works and that is not going to fail catastrophically, and that we've actually tested that condition. So we're making software work well in production, where production might be an insulin pump, or it might be a firefighter's uniform, or it might be a robot in a vertical farm. If you're interested more in kind of some techniques around this space, come and give me a shout afterwards. We've been using some of these techniques with a few different clients recently, and they've been very effective. I'm just going to pick out one, which is this one here called a runbook dialog sheet. It's a big A1 size printed sheet, so a big thing. It fits on a big table, and it has a load of criteria around it for assessing how fit for production, how ready for production a piece of software or a system is. And the idea is that you lock the team in a room, you throw away the key. No, you encourage them to fill in all the details and about the software system. If there are blanks, like if they don't know what happens when the clock changes from normal time to summertime, then we need to find out, because we don't know if that's going to cause a problem with the systems. We don't want suddenly the insulin pump to get confused and switch off because it thinks it's already given a dose. There's a few more things in there. If you're interested in these, come and give me a shout. The slides will be online shortly. Ultimately, for operability, we're really talking about long-term customer experience and viability of the software in its operating context, not just a kind of set of features that a product owner's got on a backlog, which, to be fair, is kind of the approach that lots of organizations have sort of been able to take. If you're interested more in operability stuff, then I am one of the 3 authors in this book, Team Guide to Software Operability, and I've sorted out a discount code, so 30% discount. It's on LeanPub, so we're publishing it as we go along, and it's about 60% complete right now, and we're working on the remaining bits over the next few months. So if you're interested, then follow the link in the slides. I'll maybe tweet it out, or I'll put it in the Meetup link or something. But there's some really useful patterns in there that different organizations, so we've got some case studies from different places and useful patterns for helping organizations kind of get to grips with some of this additional kind of thinking and testing around operability. And there we are. Those 4 things. So we can, as people working in this space, we can discover good practices using kind of cloud native stuff, because it's kind of easy with software. It's easy with cloud in the sense that it's very rapid. It's a very rapid iteration to discover these practices, and then we can adapt the techniques for kind of less cloudy situations. But we're in a position where we can discover these things, which puts us in a very strong position for being able to use our skills in lots of different places. And getting slightly mercenary, the market for people with continuous delivery and operability skills is looking super rosy, basically, because the world's our oyster, effectively. So, bit of further reading at the end if you want to do that. In the slides here, I'll link to a few different interesting websites that we mentioned. And that's a book I've just finished writing, which is on something completely different. It's about how teams interact. I actually have brought a couple of copies if someone wants to have a look through. that is all. If you've got any feedback, then go to confluxdigital.net/feedback and you'll find a feedback form. Thank you very much.